So in this video, we will be continuing some trig stuff, doing tangent lines and horizontal tangents. In order to find the normal or perpendicular to the tangent line, as you know, you need an x, a y, and a slope value. Starting with slope, we take derivative of the given function y equals sine x, so dy over dx equals cosine x. And since we are given the x value, we plug pi over 6 into the derivative and get radical 3 over 2, since that's the cosine of pi over 6. Then we plug pi over 6 into the original function and get 1/2, since that's sine of pi over 6. The equation of the normal is formed with the x value, y value, and negative reciprocal of the slope value. The normal line is y minus 1/2 equals negative 2 over radical 3, x minus pi over 6. Then once everything's distributed, it becomes y equals negative 2 over radical 3, x plus 2 pi over 6 radical 3 plus 1/2. And fully simplified, the normal line is y equals negative 2 over radical 3x plus pi over 3 radical 3 plus 1/2. The next example is determining where the function y equals x plus sine x has any horizontal tangents. Again, we start with taking the derivative of the function, so dy over dx equals 1 plus cosine x. Since it's horizontal tangents, we set our derivative equal to 0, then we solve for x by subtracting 1 and finding the x value at which cosine equals negative 1. So in this case, x equals pi. Once we plug pi into the original function, we get the y value we need, which would be pi plus sine pi, or simplified, just pi. The slope value is just 0 in this case. So the point slope form would be y minus pi equals 0, x minus pi. Once the 0 is distributed, you can move pi over and simplify to get y equals pi. The last example is similar to the one we just did with finding a horizontal tangent, but the function is now y equals 1/2 x plus cosine x. Take derivative of the function, so dy over dx equals 1/2 minus sine x. Set 1/2 minus sine x equal to 0 and solve for x after rearranging to sine x equals 1/2. X will equal pi over 6 and 5 pi over 6, since sine is positive in quadrants 1 and 2. Then plugging pi over 6 into the original function, we get 1/2 pi over 6 plus cosine pi over 6, or simplified, pi over 12 plus radical 3 over 2. Then doing the same with 5 pi over 6, we get 1/2 5 pi over 6 plus cosine 5 pi over 6, or simplified, 5 pi over 12 minus radical 3 over 2, since cosine is negative in second quadrant. With the x value, y value, and slope of 0, we can determine the equation for the horizontal tangent. The first horizontal tangent equation, using x equals pi over 6 and y equals pi over 12 plus radical 3 over 2 with a slope of 0, we would get y minus quantity pi over 12 plus radical 3 over 2 equals 0, x minus pi over 6. Once the 0 is distributed and the quantity pi over 12 plus radical 3 over 2 is moved over, we would get y equals pi over 12 plus radical 3 over 2. Now the second horizontal tangent, using x equals 5 pi over 6, y equals 5 pi over 12 minus radical 3 over 2 and slope of 0, would be y minus quantity 5 pi over 12 minus radical 3 over 2 equals 0, x minus 5 pi over 6. And once the 0 is distributed and the quantity 5 pi over 12 minus radical 3 over 2 is moved over, the final equation of the second horizontal tangent is y equals 5 pi over 12 minus radical 3 over 2. See me after class.